So here's a nice algebra problem. X over 1 plus x over 1 plus 2 plus x over 1 plus 2 plus 3 all the way to sum x over 1 plus 2 plus 3 all the way to n is equal to n. So you want to find such an x that this equality holds. So for example, if you take n equals 1, you will have x over 1 equals 1. Well, that's obviously when x is equal to 1. If we take something like x plus x over 1 plus 2 equals 2, this would be 3x plus x equals 6, so x would be 6 over 4. For the case when n is 3, so x over 1 plus 2 plus x over 1 plus 2 plus 3 equals 3, x plus 2x plus x over 6 equals 3. This is just 1.5x equals 3 and x is equal to 2. So we are trying to find a general formula for x such that this equality holds, right? And the first thing that I'm going to do is I will try to make the denominators something a little bit easier to work with, because right now they're not something that you can directly work with, right? So if you have any 1 plus 2 plus 3 all the way to some, let's say, a, then this is equivalent to a multiplied with a plus 1 divided by 2. I proved this earlier on a video. So for example, 1 is equal to 1 multiplied by 2 divided by 2. 1 plus 2 is the same as 2 multiplied with 3 divided by 2. 1 plus 2 plus 3 is the same as 3 multiplied with 4 divided by 2, and so on. So the reason why I'm doing this is because multiples would be, if you have multiples in denominators, that would be easier to work with rather than plus sign. So we can, first of all, let me factor out the x. We would be left with 1 over 1 plus 1 over 1 plus 2 plus 1 over 1 plus 2 plus 3 all the way to some 1 over 1 plus 2 plus 3 some n, and this should equal n. And what we can do is we can replace all the pluses in the denominator with 1 multiplied with 2 divided by 2, and then for 2 it would be 2 multiplied with 3 divided by 2, and then 3 multiplied with 4 divided by 2, and this pattern continues on up to some n multiplied with n plus 1 divided by 2, and of course this should equal n. And just for convenience, we can also further simplify, take all these 2's common. So 2x multiplied with 1 over 1 multiplied with 2 plus 1 over 2 multiplied with 3 plus 1 over 3 multiplied with 4, and you continue on to 1 over n multiplied with n plus 1, and of course this should equal n. Okay, so here's the thing. I have some 1 over a multiplied with a plus 1, right? And what I can do is I can split it up into its partial fractions such that it will be some number over a plus some number over a plus 1. And for example, if I take something like 2 over x plus, let's say, 1 over x plus 2, I can cross multiply, and in the denominator I will be left with 2 multiples, and you can expand such that this would be 3x plus 2 divided by x plus 2, right? So this thing is equal to this thing, and it's pretty easy to go from here to here. You just need to take common and stuff. Going from here to here is what called that you're taking partial fractions. So here I have created an equality, and what we can do is we can multiply the whole thing by a and a plus 1. So this would be 1 is equal to a multiplied with a plus 1 plus b multiplied with e. Couple of methods to do this. We can say that when a is equal to 0, 1 is equals to a, plus 0, and when a is equals to minus 1, 1 is equal to 0 minus b. In other words, a is 1 and b is minus 1. So what we arrive at is that any fraction where you have one number multiplied with the next number, it can be written as 1 over a minus 1 over a plus 1. So for example, if you have any, let's say, 1 over 3 multiplied with 4, that's the same as 1 over 3 minus 1 over 4, right? Simply because what you can do is if you if you try to take LCM, what would end up happening is that you would do a plus 1 minus a and then divide by, of course, the multiples. Right, and so what we can notice is that it ends up with 1 minus here, and we can set up something what's called a telescoping series. So let me copy this down here. 2x multiplied with 1 over 1 multiplied with 2 plus 1 over 2 multiplied with 3, 1 over 3 multiplied with 4, and all the way to sum 1 over n multiplied with n plus 1, and this should equal n. So we can split these up into 1 over 1 minus 1 over 2, right? This is me splitting up this part, and then this thing, let me choose a different color, this thing will be plus 1 over 2 minus 1 over 3, and then this thing will be plus 1 over 3 minus 1 over 4, and this continues on until you reach, of course, over here, which would be 1 over n minus 1 over n plus 1. And so what you will notice is that the consecutive terms will cancel out. So this minus 1 over 2 came from here, and this plus 1 over 2 came from here, and of course they will cancel out each other. So these two cancel out each other, these two cancel out each other, and this will continue on. This will start cancelling out, and it will cancel out. The last thing that it will cancel out is the 1 over n, because if you move one step backwards, there would be a minus 1 over n, and so it cancels out. So in the end, after all this pairing, what you're left with is 2x, and then there's 1, and all this stuff cancels out, and you're just left with 1 over n plus 1, right? And this should equal n, right? And this is something that you can easily work with. So x will be equal to n divided by 2, and then 1 minus 1 over n plus 1 is basically n over n plus 1, and this thing will cancel out this thing, so x is simply equal to n plus 1 over 2. In other words, if you have n plus 1 over 2 divided by 1 plus n plus 1 over 2 divided by 1 plus 2, and you continue on until n plus 1 over 2 divided with n plus 1 plus 2 plus all the way to sum n, this would be equal to n. And we are done. QED.